And now, we are going to talk about application to binomial expansion and other important and helpful formulas. Number 1. Pascal triangle gives us the coefficient for an expanded binomial of the form x plus y raised to n, where n is the row of the triangle. The binomial theorem tells us we can use this coefficient to find the entire expanded binomial. Number 2. As we move to the right, we subtract 1 from x's exponent and add it to y's. To put it simply, x raised to n, y raised to o is equal to x raised to n, where the sum of the exponent of all variables per term of an expanded binomial should be equal to the exponent of its non-expanded form. Now, number 3. When a binomial has a plus sign, such as x plus y raised to 2, all of the terms of the expansion are positive. When we expand a binomial with a negative sign, such as x minus y raised to 2, the first term of the expansion is positive, and the successive terms will alternate sign. For example, by expanding x plus y raised to 2, through distribution, x plus y times x plus y, x squared plus xy plus xy plus x squared, or we get x squared plus 2xy plus y squared, where the coefficients are 1, 2, 1. Similarly, these are the numbers appear in the second row of the Pascal triangle, while the exponent are 2, 0, 1, 0, 2, 0. The sum of each exponent per term is equal to 2. Next example, by expanding x plus y raised to 5, we get x raised to 5 plus 5x raised to 4 y plus 10x raised to 3 y raised to 2 plus 10x raised to 2 y raised to 3 plus 5x y raised to 4 plus y raised to 5, where the coefficients are 1, 5, 10, 10, 5, 1. Similarly, these are the numbers appear in the fifth row of the Pascal triangle, while the exponent are 5, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0, 5. The sum of each exponent per term is equal to 5. Now, for finding specific entries within Pascal triangle, by using the formula n factorial divided by k factorial n minus k factorial, which is similar to the one we usually use for combination NCR. We can find the third number in row 6, which is k is equal to 3 and n is equal to 6 of Pascal triangle. By substitution, we now have 6 factorial divided by 3 factorial, 6 minus 3 factorial, which is equal to 20. 1, 6, 15, 20, 15, 6, 1. 20 is being the third number of the 6th row counting from 0 left to right. Since we know that when we're expanding binomial as we move to the right, we subtract 1 from x's exponent and add it to y's, where x raised to n minus 0, y raised to 0 plus 0, x raised to n minus 1, y raised to 0 plus 1, plus x raised to n minus n, and y raised to 0 plus n. For example, by expanding x plus y raised to 2, we get x raised to 2 plus 2xy plus y raised to 2, where the exponent are 2, 0, 1, 1, 2, 0. 2 being the sum of each exponent per term is equal to n. Knowing the formulas for finding the coefficient and exponent, we can combine them as one to form a general formula, where r is equal to k. X plus y raised to n is equal to n choose 0, x raised to n minus 0, y raised to 0, plus n choose 1, x raised to n minus 1, y raised to 0 plus 1, plus n choose 2, x raised to n minus 2, y raised to 0 plus 2, plus n choose n, x raised to n minus n, and y raised to 0 plus n. Sample problem. Your pet chicken laid 5 eggs, and you want to know the probability of getting 3 female chicks and 2 male chicks. In binomial expansion, it corresponds to f plus m raised to 5. If we expand it, we'll get f raised to 5 plus f raised to 4m plus 10f raised to 3 m raised to 2 plus 10f raised to 2 m raised to 3 plus 5fm raised to 4 plus m raised to 5, where 10f raised to 3 m raised to 2 is equal to the combination of 3 female chicks and 2 male chicks. We divide the coefficient by 10, the sum of all coefficient, and we get 10 divided by 1 plus 5 plus 10 plus 10 plus 5 plus 1 is equal to 10 over 32. We divided it, we get 5 over 16, and we divide it again, we get 0.3125, and we're gonna multiply it by 100, and we get 31.25%. We now have the probability of getting 3 female chicks and 2 male chicks is 31.25%. Randomly picking 5 donuts out of a dozen, how many possible sets of donuts are there where order does not matter? Here we can use the formula and choose R. And we get 12 factorial divided by 5 factorial, 12 minus 5 factorial, and we get 479,001,600 divided by 604,800, and then we get 792. Similarly, we can use this formula for finding the fifth term from the 12th row of the Pascal triangle. By using the general formula, we can find the fifth term of x plus y raised to 25, being that x raised to 25 as the zeroth term, and 25x raised to 4, 24y as the first term. N choose 0, x raised to n minus 0, y raised to 0, plus n choose to 1, x raised to n minus 1, y raised to 0 plus 1, plus n choose n, x raised to n minus n, y raised to 0 plus n is equal to 25 choose 5, x raised to 25 minus 25, y raised to 0 plus 0 is equal to 53,139 x raised to 20 y raised to 5.